All right. So what we had talked about yesterday, we had listed it on your previous page. If you have those notes on the previous page, we talked about isolating the square term. So in this case, this whole quantity is getting squared. So what we talked about yesterday is the first thing we need to do is to move that 5 over, and you would have done that by adding it, and that gets that to go away. And then now that quantity that's squared is just multiplied by a 2, and it's equal to 162. This still is what we're trying to get by itself. So the 2 that's getting multiplied by it, the way we undo multiplication is through division. So we would now divide by 2 to cancel that out. And then we finally have the squared term isolated, and then that would equal 81. All right. So then from there, that was our first step that we had listed in our lines on the previous page. The second step was then to eliminate whatever the power was. And in this case, it's a square. So the way we get rid of that is with a square root. So on both sides then, you're going to take the square root of both sides. But then we have to understand, not only do we get this x minus a 4 here and a 9 here, but there is a positive and a negative number that we could have squared to get 81. So that 81 square root really could have been a positive or a negative 9. That really then gives us two different answers. So the way we then got those two answers is this really sets up two different equations. One of them is the x minus a 4 set equal to this 9 as if it's positive. So notice how I just highlighted the positive there. So you're going to set it equal to the positive 9. And then the other solution we're going to get by doing x minus 4. And then we're going to set this one equal to this negative means this could also be treated as a negative 9. So that one we treat with a negative 9. Then you have two very simple little equations there to solve. So I'm going to go into the next problem here. But if I add 4 to both sides now, just cross that out, these will cancel, and one answer should be 13. If I go to the second one, do the exact same thing, add 4 to both sides, the negative 9 plus 4 is a negative 5. So then those are our two answers. And like we showed yesterday, if I were to take this here, we won't go through all of it in this case, but we can test this. And then I guarantee if we took this 13 and plug it in for x right here, it's going to make that equation true. If we take the negative 5 and plug it in for this x up here, it will also make that equation true. So we can test our answer still just like we did with regular linear equations back in the day. All right. So that's a good one to understand our steps. Isolate the squared term, then get rid of that squared term, and then just solve the equations that we end up with. All right. Now, the ones we skipped over a little bit were kind of the ones that Ahmed had asked about yesterday. What if these are not nice numbers? So most of them have been nice. 12 is the only one that wasn't a nice number. But what if we don't get nice numbers like 14? Well, we'll go through these and you'll see what we're referring to now. So number 13, look at your squared term. So here's our squared term in this case. That's what we want to get by itself. It's currently getting multiplied by a 16. So in order to get rid of that 16, we undo multiplication through division. So we're going to divide each side by that 16. Once we've done that now, you have this x minus a 2 quantity squared. You look at your 9 over a 16. Again, we don't really want decimals here. When it comes quiz time, test time, we want to leave this as fractions. We want to leave these as radicals. A 9 over a 16 doesn't reduce. There's not a common factor that goes into both of them. I don't want to see a decimal there, so we just leave it as a 9 over a 16. The square term is now isolated, so we want to get rid of the squared by doing the square root. So we're going to take the square root of both sides. So on the other side, I do the square root knowing that I should get a positive and a negative answer to that square root of 9/16. So on the left, we get an x minus a 2. And then on the right, remember how we did a fraction. All this really means is I do the square root of the numerator over the square root of my denominator. I know both of those. The square root of 9 would have been a 3. And the square root of 16 is a 4. But again, we should have a positive 3/4 and a negative 3/4. Just like we did at the bottom, this now gives us our two different equations. So the first equation, we do the x minus 2 set equal to a positive 3 1/4 or 3/4. So that equals 3/4. And then the other equation you're setting up, you do x minus 2 equals, and then we have to understand this also means we have a negative 3/4. So we set that one equal to the negative 3/4. Then two pretty simple little equations there. You're going to add 2 to both sides in both of them, and then whatever that gives us should be our answer. So if I do plus 2 here, again, I'm going to have to erase, but these will cancel. If you gave me a decimal here, that's okay. Like 3/4 is 75 cents, correct? And then you're going to add $2 to that. So if you give me 2.75, that would be okay. I'd be all right with that for one of the answers. If you want to write it as a fraction, that would be 11/4. Depends on how your calculator is set and how you're going to do it. And then the same thing over here. Add 2 to both sides. That's going to cancel. And then when I do $2, so think about this as a positive $2, and I'm going to subtract 75 cents. I'm going to subtract 3/4. That leaves me with $1.25. So our other answer would be 1 1/4. Okay, or you can write it as that 1 1/4, 5/4, however you want to express that. All right. Okay, 14. Notice there's a cubed there. We want to leave that. I would give you some cubes. I would expect you to be able to handle cubes. Number 17, I had you get rid of the 4th, but a cube power is reasonable. This is one that I would anticipate being able to give you. So 14, do the first 2 steps. Go ahead and take or isolate in this case, the cube term, then get rid of that cube term, and then see what you think. And then this one we need to talk about a little bit once we get to that step. So do at least the first couple of steps. All right, so first step is to isolate this, and now in this case, the cube term. So we would want to divide by 2. So we do that. That gets the cube term by itself, which is our goal. That then should equal a 27. We dealt with this briefly together, and then you would have dealt with this a little bit briefly last year with Math 1. We now need to get rid of this cubed. So every single time, like if we look at number 13 that we just did, the reason I'm using a square root, and the reason we know it's a square root, there's not a number written inside with that index number. That means it's implied to be a 2. But we use a square root to get rid of a square. If I now have a cubed power, the way we get rid of a power that's a 3 is we now need to use that radical again, but we want to be doing a cubed root. So we want to put a little 3 in there as our index number. Then it's still regular old algebra. So whatever I do to one side, I've got to do to the other. So I now need to do the cubed root of 27. So by doing a cubed root, so by taking this cubed root symbol, it gets rid of the cubed power, and all I am left with on the left is the x. And then that would equal, now we have to remember those perfect cubes that we dealt with a few days ago. All right, so perfect cubes are like 1 cubed is a 1, 2 cubed is 8, 3 cubed then is a 27. So the number 27 is a perfect cube of 3. So when we do the cube root of 27, that should just give us a 3. That's what we cubed to get a 27. But then, hopefully, at least in our head, if we're following, paying attention well, we're wondering, do I need a plus or a minus here? Because every other one, we've had a plus or a minus, correct? Like every problem I say, you should get that plus minus sign. All right, so now let's talk about this when we have a cube, whether we need that or not. So think about x squared equals 25. The reason we get a positive and a negative, because not only does 5 squared give you 25, but also a negative 5 squared would give us a 25. So there are, in fact, 2 answers to this. If I do this one, if I square 10, that's going to give me a 100. And if I square a negative 10, that will also give me a 100. All right, that's why we get 2 answers for this. So now let's go to the problem that we are dealing with, where I give you x cubed equals 27. So that's this step right here. So if I do 3 cubed, So that's this answer. If I say it's a positive 3, 3 cubed gives us 27. 3 times 3 times 3 is 27. So that's definitely an answer. But let's say I turn this into a negative 3. Does a negative 3 times a negative 3 times a negative 3 give you a positive 27? No, it's going to give you a negative 27. So our only answer here is a positive 3. So when we have these cubes and we take the cubed root, we don't do the little plus minus. That's only for our square roots. All right. So if it's a square root, we want the plus minus. If it's a cubed root, we're not going to use that plus minus. All right. So that's something to be very, very careful of to make sure we differentiate the difference in those two problems. All right. All right. A couple more of these. 15. The squared term is by itself, so we're all good. Nothing we can do with it. There's nothing attached to it. So you're ready to take the square root of this right away. And it's a squared again, so we just do a regular square root. So that means on the other side, you're going to do a regular square root also. So the square root cancels out the square. We're left with an x plus a 5. On the right-hand side, we now have a plus or a minus, but now kind of Ahmed's question. We dealt with one yesterday. The next two gets to this, where this is not a nice number. It's not a nice perfect square. So what we're going to have to do with the root 8 is try to break that down. So we're thinking two numbers that multiply to be 8, with one of them as a perfect square. So that would be 4 and 2. Left-hand side, just rewrite it initially until we're done with the right-hand side. But on the right-hand side now I have a positive and a negative 2 times the square root of 2. So now it's up to you with these radicals. So we can still set up our two equations. We can say x plus 5 equals the positive 2 root 2. This is probably not a bad idea, really. And then you can do x plus 5 equals a negative 2 root 2. Totally fine. The issue is, and again, when I do these multiple choice, this I am not going to give you as a decimal. So when those cancel, so we subtract 5 from both sides, the way I would then have you write this answer, and you start writing smaller here so I can squeeze all this in. The way I would have you write this final answer, let me do this, that. So I have a little room. The way we would write this is the x is by itself on the left-hand side. And then I would just write this as 2 root 2 minus a 5. We can't put those together. One of them is a radical, one of them is a not. So you just do 2 root 2, and then you subtract that by 5. Do not plug that into your calculator on the quiz or the test and give me the decimal answer. Okay, you will not get credit for that. All right, we want it to be exact. So the second one, same exact thing. I'm going to subtract 5 from both sides. These are going to cancel. So I get the x on the left. And then you're going to basically do the same thing. Take this negative 2 root 2. You're going to put that first. And then I'm going to decrease that by 5. But since these aren't like terms that we talked about the other day when we add and subtract radicals, we can't do anything with them. So we just leave it as that difference. So this is one of our answers. This is our other answer. All right. So last one of these on your paper. So I'm going to give you a minute, see if you can get through this one. And then we still have some more to do underneath, but it's a little different type of a question. Try number 16, see what you think. So get that squared by itself, get rid of it, solve whatever results, just kind of go through all those steps and see what we can get to. If you can do this one, you're in pretty good shape right now. This would be one that I would anticipate some major problems come a quiz or a test. I hope the first few steps we can get through, and then it's really kind of that end when you don't get a nice number, how we can handle that, or it gets a little weird. All right. Okay, let's see how far along we are. That first step, hopefully we have to have that down. You want to get that square term by itself, so we're going to get rid of the 3. It was getting multiplied, so we undo multiplication via division. So you're going to divide by 3. Then that square term is now by itself, so then we have to do our square root to get rid of a power of 2. That then means we have to do the square root on each side, knowing that square roots give us a positive and a negative solution to this. So the square and the square root cancel. All that leaves me with on the left is the x minus a 1. On the right-hand side, though, maybe I should have given you a different one because you really could have modeled number 15 here, hopefully. We get a square root of 8 again, so that's just a 4 and a 2 in order for us to be able to simplify this. So x minus 1 would equal a positive and a negative. This becomes a 2, regular 2, and then we still have the radical 2. At this point, you're ready to solve these to get your 2 different equations. You're going to take the x minus a 1, set it equal to the positive 2 root 2, and then the other one, you're going to do your x minus a 1 and set it equal to a negative 2 root 2. Since these are not like numbers, it's just going to kind of look weird, but we need to add 1 to both sides. We cannot do like a 3 or a 3 root 2. All right, this is a radical, this is not. So you just write this as the sum of those 2 terms, a 2 root 2 plus a 1. And then over here, when I add 1, the same thing. We just write that as the sum of the negative 2 root 2 and then the positive 1. Got it? Good. All right. These can get pretty hard. All right. These can be pretty tricky depending on how hard I want to make them. So you want to be on top of these. Okay. This is one of the harder things that you will find you're going to have to do with what we've done so far this year. Okay. Last thing real quick, because there's another way we're going to solve these. Just a little review of some factoring here, at least a couple. See if you remember how to factor that. Factoring is when we did what 2 terms would have multiplied together to give us that x squared plus 11x plus a 24. This is when we did the little area model. If you wanted to draw in the little rectangles, all right, that's the way we kind of organize this. When we get to 22 and 23, I would suggest maybe doing that. All right, so we're looking for numbers that multiply to be 24, add up to be 11. What do you got, Cam?
X plus 8 and x plus 3.
Good. The x and the x multiply to give us this x squared, and then the 8 and the 3 multiply to be 24. When we add 8 and 3, it's going to give us the 11. So that's our factored version. All right. 19, same thing. We want to come up with numbers that multiply to be 18, but will add up to be a negative 9. Since we have an x squared here, we know this has to be an x times an x. But then we want to come up with a combination of numbers that add up to be 18 and multiply to be a negative 9. All right. So again, many ways to get 18, but in terms of the ones that have to, so notice our pattern too. They're multiplying to be a positive 18, but they're adding up to be a negative. So the only way that's going to work is if both of our numbers are negative. All right. So the two numbers that multiply to be 18 then, and then add up to be a 9 should have been the 6 and the 3. All right. So x minus 6, x minus a3. All right. So little review there, just to make sure we're going to be able to do those. I'm not going to give you any more of those. There's two things I want you to now be aware of. You have an assignment on this tonight. So if you have the packet in your homework packet, you can go to that. Let me pull it up what page it is. So it's page 12. And then you're going to do numbers 1 through, it's basically these 2 pages, 1 through 20. And the first 6 should be very quick and easy. So that's the homework for tonight. You're going to put that underneath the assignments. If you don't have the packet, just click on the assignment on your Canvas page. When you click on it, if this will open for me, and you'll see the assignment there. So you can look at the problems, you can print it if you want. A lot of us did not pick up the packet, so I'm assuming we're just printing or looking at this, okay? So make sure we get that done for tomorrow at midnight. And then for the last 10 minutes, what I want to now kind of see is where we're at with this stuff. So we have a little pop/quiz/ little check on what we just got done doing the last 2 days. I want to see where we are at. So same place where we do our little tests and quizzes. You're going to log into that right now. I gave you 10 minutes on this to do it. And that's how much class time we have left. And I want to see where we are at with what we've just done these last 2 days. So you need to go to examlogin.com. This is first period, right? Yeah. Those are your codes. It says show all work, so make sure I can see this. So I left you the notebook paper that you can use your mouse to write on. So make sure you show me all your work. And there'll just be a couple points each, but I want to see where we're at and to make sure we can do all of this. All right, so go to that, and then you got 10 minutes. When you are done, you can check out, and you have 10 minutes to do it. All right. If you have any questions, let me know.
How many points does it work?
They're 2 points each.
Okay.
Make sure I see the work also. Make sure you're showing with your mouse how that's all playing out.
So, are you having any issues? I see you still haven't logged in yet. Yeah, I'm putting in the codes right now. Okay.
right, so then again, some of you I'm seeing are finishing. Once you're done, just make sure you know what the homework is for tomorrow night. That place on the assignment is set. But once you are done, this is submitted with all the work so that we can see the work, then you guys are free to go. Okay.